But these are your seats for this week and a little bit we have next week. So please know the names of your group members. Saying that girl with the long hair, not especially descriptive as that is. I would say all of the girls in this room. So know who you're working with. And please give a little bit more information about. We were all there all day and we worked together. We were good. Gosh. So some of you had lovely, cute answers to my if math was an animal. I've never seen people give octopus before, and like 5 of you did.
Be a parrot.
One kid, it would be a dead parrot.
Oh.
Why a dead parrot? I don't know, but
Just looks like it.
yeah. And some of you were like,
See words.
oh, it's one of those cats, it's all cute and cuddly, and then it turns psycho and slashes you.
Like, give me a word.
I know,
Anyway,
Oh, elephant.
so
it's not hard.
today.
Giraffe.
See it all.
It's just a vibe I get.
Not a great idea.
Tissue box. That's a pigeon.
The numbers.
That's
I think it was.
What's Joke. That's outrageous.
Well. Can you guys still see? All right, so, couple of announcements. Please read your emails, and if you don't see email, go on to Canvas and check announcements, yes.
Flash your email with the retakes.
Yes.
I was looking and I cannot find either of my emails, the link to do the.
Okay, so as I was just saying, check your email or going to Canvas, check announcements, because announcements are how I send you guys the emails. And right here, there's the peer review thing, and here is the link to sign up to take a quiz, retakes. So on here, I ask you to fill this out by the end of school today. That's the end of this class period. I realize you guys don't read your email. Please do that. I don't send a lot of email, and when I do, they are largely important for you. So you can choose one exit card or none. They're all named here and how many points they are. And you may take one quiz or none, and that's it. You do not need to do exit card corrections. You do need to do quiz corrections. One person has turned them in already, and I've graded them, and I'll get them back to you by the end of class today. And I also ask that you tell me when you're going to take it. These are your options. So this Friday or Monday, okay? I need some time to grade them. Grades are due Wednesday. So I can't squish things any further. So if you can't find this message in your email, check Canvas and announcements. And I will lock the Google form more like 5 o'clock, give you some time so that you're not checking and trying to do this in class now. But what you may not do is show up on Monday at lunch and say, so I'm going to retake these things, and not have signed up for them. I won't have the exit cards copied for you. I won't have a quiz copied for you. And the answer will be no. You need to know in advance that this is what you wanted to do. You needed to have studied for it and do better on it the second time. All right? So, any other questions about stuff? All right. back to trig. I wanna show you why unit circle works. And it works because of special right triangles. Those special right triangles, there were two of them. Does anybody remember what they were? From, yeah, Teddy?
45, 45, and 36.
45, 45, whew, 90, and
30, 60.
30, 60, 90. Okay, and the way that those triangles were created, this first one, we have a square. Squares, all the corners of a square, 90 degrees, all the side lengths are the same. So, if this side is 1 and this side is 1, what is the h value? Pythagorean theorem, 1 squared plus 1 squared equals the hypotenuse squared. So, in your notes, could you guys draw that? 45, 45, 90. It's an isosceles right triangle. Isosceles from geometry, two sides are the same. Which two sides? The two sides that are across from the two equal angles. And if I made that square bigger, so pick a number. 4. So if I said these side lengths, oh, they were 4, what's the hypotenuse? It's gonna be 4 root 2. Griffin, pick another number. 6, all right? If this is 6, what do you think the hypotenuse is gonna be?
6 root
6 root 2. And if it's 60, 60 root 2, 6,071. Okay, the hypotenuse is 6,071 root 2. Okay, yeah? Okay, so this is one triangle you needed to know. The other triangle you need to know is this guy. Equilateral triangle. What does equilateral mean?
Equal sides.
All angles are equal, that's actually equiangular, but if it's equilateral, all sides equal, all the angles are gonna be equal also. So Joseph, if all the angles are equal, how much is in each angle? 60, because 180 inside any given triangle, so all the little corners are 60. That hypotenuse, height, that altitude's heights go straight down. If I measure my height and I go off to the corner of the room, I'm 12'8", then I'm like the best player in the WNBA. But no, heights go straight perpendicular down, yeah.
Why is the hypotenuse one of the
It is not the hypotenuse, it is the height.
Oh.
So I called it H, not for hypotenuse, but for height. If you wanna give it a different letter, feel free. But doing Pythagorean theorem, you're right that it's a leg, so it's 1 squared plus h squared equals hypotenuse squared. So h is the square root of 3. So that's another template that you guys should write in your notes, which I will put somewhere nicer. Oh, not that much nicer. Dora, the shortest side is across from which angle? The biggest angle, smallest angle, or the medium angle?
Smallest.
Smallest. Is it always gonna be that way? Smallest side across from the smallest angle? Yeah, absolutely. The biggest side is across from the biggest angle. So, if you can remember 1, 2, almost 3, okay. Roll square root of 3. Is that bigger than 2, less than 2? Which way does it go?
Less than 2.
Less than 2. Because square root of 1, square root of 3, square root of 4, Well, square root of 1 is 1, square root of 4 is 4. They go in that order. Across from the smallest one, as Dora said, is the smallest side. Across from the biggest angle is the biggest side. Like, figure out however you can to memorize this triangle and this triangle, because that's how you will do unit circle, and unit circle will be in your face for months. And if you choose to go on to calculus, it will remain in your face. Like, y'all can't forget it. Homework tonight is special right triangles and radians. I will try very hard to get to the radian stuff in here, no guarantee. Again, retakes are this Friday and Monday at lunch and before school. Check the announcements or dig through your email. Announcements are probably easier to find. And on Monday, we will have, however far we got through trade, we will have a small quiz on trade. So, hopefully you guys have these 2 triangles in your notes already. So if, let's see. Eden, what do you think about this? It's an isosceles triangle. What do I know about X and Y?
The side and or that they're both one.
They're, whatever they are, they're the same. Thank you, Dante. Because it's isosceles, the sides across from the equal angles are going to be equal to each other. So whatever X is, Y is. Whatever Y is, X is. Okay? Kamal, do you remember geometry? Sorta. Do you remember anything about similar triangles? They're a shrink and a stretch of the same shape. So, if this is a 45-45, and that's a 45-45, every side over here is gonna be 1/3 of whatever these sides were. They're gonna be proportionally stretched or shrunk. Okay. What does that mean? Not sure it matters to you. How I yes. Sure. How I suggest solving for things, like, what is Y? Okay. I wanna know the Y value. Across from 45 is Y. Across from 45 over here is 1. Across from 90 here is 1. Across from 90 here is the square root of 2. So, what is the Y value with numbers? What is Y over 1? It's Y. What is 1 over root 2? You know what? It's 1 over root 2. And, alright. Last year they made a big deal, no radicals down there. How do I get the radical out of the denominator? Yeah? Any idea how? I can't just move it. Liffy, would it?
Multiply both sides by root 2, and then so root 2 it just becomes over 2.
Okay, it's not both sides, it's the top and the bottom. So basically, I'm multiplying by 1. It's a funky looking 1, but it's a 1. Multiplying square roots. Well, 1 times root 2. Does anybody remember how to multiply square roots? Square root of 2 times square root of 2? It will be 2, because it's the square root of 2 squared, which is just the thing inside. Some of y'all don't like that, so inside times inside, leave it inside. Well, do we know what the square root of 4 is? 2. So, I am fine if you leave the number as 1 over root 2. If they say rationalize or get the radicals out of the denominator, or it's multiple choice or a standardized test, you need to know that that is the same answer. Griffith, good morning. Lorenzo, over here, I wanna solve for y. Can you tell me a ratio, like y to what equals what to what in this other triangle? So this was across from 30. What? So what is the across from 30 in the triangle that we're supposed to have memorized? What number? What actual number is it? 1. Okay, and what's the actual number in this triangle that I know? Do I know the value of x? Do I know the value of y? Do I know the value of 1? 1 is 1, so in this triangle, across from 90 was 1. What's across from 90 in the triangle I'm asking you to memorize? 2. So what is the y value?
1/2.
1/2. Okay, Angel, you ready? I need x. X is across from 60, so what am I gonna put on it?
Putting in a square root of 3.
And the one size that I know here is the across from 90. Is the across from 90 there?
2.
2. Amory, now I don't have x all alone. Here I had y over 1, which is just y. Here I don't. How do I get x by itself? Okay. If this is what I'm asking, how do you get x by itself? Multiply both sides by 2. So it's gross, you guys don't like it, you get paralyzed when it's like not a pretty number, but all numbers are beautiful. Don't hate because it looks different. Same thing, just what you would have done over there. You multiplied by 2 on this one, we'll multiply by the dude down there. Alright, happiness and joy. Yep.
How'd you get this, how do you get, the square root of 3 over 2 when you multiply it by the square root of 3 times 2?
Okay, so Amory said here, to get x all alone, she would have multiplied by 2 on that side. So she's gotta do the same thing on the other side. She multiplied by 2. So over here, she was like, alright, I got it now. That was dividing by root 3, so now I've gotta multiply by root 3. I multiply by root 3 on this side. I need to multiply by root 3 on that side. This guy's a fraction over here, so this root 3, he's on the top. I'm gonna write the little number 1 on the bottom. Top times top, bottom times bottom, there you go.
I got it.
Okay, so here's how we're gonna use these things, Adele. If you guys don't have this written, write it. And maybe if you have it written, write it again, because repetition is how the memorization starts. I need you to memorize this triangle. (45, 45, 90). The side lengths are 1, 1, root 2. Dante, do you have a question, or are you gonna give us an answer?
For sine of 45, it goes down to the square root of 2.
For sine of 45, is it 1 over the square root of 2? Yes, it is.
Would cosine be the same thing?
And would cosine be the same thing? Yes, because opposite 45 and adjacent to 45, they are both the same length.
Is tangent 1 over 1?
Is tangent 1 over 1. Can I just write 1?
Yeah.
Yeah, because tangent is opposite over adjacent. Dante's all happy. He's like, I'm getting this. All right, Ella, cosecant of 45. Cosecant is which trig function upside down? Sine, yeah. So Frey, what is cosecant 45 then? Okay, so sine is opposite over hypotenuse. Cosecant is hypotenuse over opposite. Square root of 2 over 1. Do I need to write the over 1? Is it fine if I do? Sure. I'm not going. Virginia, what is secant of 45?
Square root of 2.
Square root of 2. The secant is cosine upside down. And I'm not gonna be this nice, but for today, we're gonna like leave it this way, that I am putting the reciprocal functions next to each other. So Byron, what's cotangent of 45? 1. 1 turned upside down is still 1. All right, ready? Tyler, you doing okay? Sophie's writing, Chrissy is writing. So unit circle, right there, cotangent of 45, 1. And eventually, if I flip it this way, the lengths and things are still gonna be the same. There's gonna be some common ratios. Sine of 45, sine of 135, they're gonna be the same. We'll get there. Okay. If you haven't written this one already, write this triangle. If you have written it already, maybe draw it again and label the sides. Great, do you think you can tell me how to label the sides?
Yeah, so the shortest side is the short, is across from the shortest angle, so that would be 1.
So the shortest side is across from the smallest angle.
The one
That's
on the right is gonna be 2.
the upright leg, this guy,
Yes.
is that the longest side?
Oh wait, I thought it was like the hypotenuse of root 3.
Okay, what number is bigger? Is the square root of 3 bigger
Oh,
than
sorry,
2?
2 is bigger.
2 is bigger, so
The longest, yeah. Okay, gotcha. That's what Finally.
but, great. If you wanna think about it as
Right.
square root.
Yep.
Okay. So Zara, given the labels of the triangle that Gray just gave us, which if you memorize the triangles wrong, you will get pretty much every unit circle question wrong. So you need to have it right. So looking at the triangle as it's labeled now, because it's labeled correctly, what is sine of 30? 1/2. Stuart, what is cosine of 30? Cosine is opposite adjacent hypotenuse, whatever what.
So it should be, 1/3.
Okay, so from the angle 30, cosine is adjacent opposite hypotenuse, whatever what. Adjacent over hypotenuse, so what is the adjacent to this 30-degree angle?
Root 3.
Over, what's the hypotenuse?
2.
So what is cosine of 30?
Root 3 over 2.
Okay. I'm like, you're saying it, but you're saying it under your breath. Chrissy, what is tangent of 30?
1 over square root of 3.
1 over the square root of 3, and if they make you get the square root out of the bottom, it's gonna be root 3 over 3, which is gross. Ignacio, what is cosecant of 30?
2.
Yes. Faustina, what is secant of 30?
2 over root 3.
2 over root 3. Isla, cotangent of 30?
Square root of
Just the square root of 3. Okay? Anya, sine of 60. So now we've got, now we're looking from here.
Square root of 3 over 2.
So the opposite has now changed because our perspective has changed. Kamal, what is cosine of 60? 1/2. in tangent of 60?
Square root of 3
Good
over
afternoon,
y.
Barron. This is Misty Castro. Pardon the interruption. All after-school activities and sporting events are canceled. Again, all sporting events, practices, off-campus practices, and activities are all canceled. Thank you.
It's already in 2 minutes.
What's the
Say it's 15.
Okay, so, all right.
I believe you.
But guys, knowing these two triangles, you have almost all of the unit circle. There's one more thing and then you'll have these two triangles and you know everything. I do need to show you one more thing. I need to explain to you what a radian is. Have you guys heard of radians? Yes? Good. What is a radian? Okay, he'll tell us. Oh, God, go away. Come on.
Diameter.
So you guys are used to degrees? They thought it took 360 days to go around the sun. So engineers hate that one. Okay, what the hell does that mean? He's gonna pick up the radius and drip the radius along the outside. Wraps it around. Here's a radian. Here's another radian. Here's another radian. All of them, they look different sizes, but look, stacking them up is the angle, no matter what the size of the triangle, the angle's all the same. Look, 2 radians. How many radians go all the way around a circle? 2 pi. Let me show you. Bell didn't write that, y'all. Let me show you. 2 pi. Pi is 3.1. Okay, so here's my circle cut into radians. There's 1, 2, 3, 4, 5, 6, and a little tiny bit. 6.28.
These are the same, y and x are the same. These both.
How many radians?
Yeah, for this
Not
one,
3.
for the 36.
5.
I don't know why you put y over 1 and why you do that. Oh, I get where she's getting.
How many
at, but I
radians?
don't know which one.
5 or 2.
Oh.
Bye, guys. Please write down homework.
I hope.